Lesson 3.6, using quadratic formula and the discriminant. It's best standards MA 912.AR.32. Something about the quadratic formula. Remember, the solutions of the quadratic formula have to be in the form of ax squared plus bx plus equal to 0. A cannot be 0, and we will be using the formula that says x equals negative b plus or minus square root of b squared minus 4ac all over 2a. In example 1, it says, at the World Championships pumpkin chunking contest, pumpkins are launched hundreds of yards. The path of a pumpkin can be modeled by, and they gave us an equation which says the height is equal to negative 16t squared plus 124.4t plus 42. The height is going to be in feet, and the time is going to be in seconds. So in order to solve it, you need to first rewrite the equation to say 0 equals negative 16t squared plus 124.4t plus 42. Again, the easiest way to do is label the parts. The negative 16 represents the A value, the B value is going to be represented by 124.4, and the C is going to be the positive 42. And all we're going to do is substitute in. So we plugged into the formula, negative B. So since B is positive, it's negative 124.4 plus or minus the square root. We filled in 124.4 squared minus the 4 times the A times the C, all divided by 2 times the A value. When you go through the math completely and you get to the bottom, you're going to have a situation where you're going to have a plus minus situation here. So you're going to split each piece. So you can be 124.4 plus the square root of 18,163.36, or the 124.4 minus the square root of 18,163.36, all divided by 32. When you plug them into the calculator, the square root of 18,163.36 is actually equivalent to 135.77, and then you're going to apply it into the math. So you're going to add 124.4 to it and then divide by 32, and you get 8.10. When you do the 124.4 and subtract it by the 135.77, it's going to give you a negative result that you divide by 32, and you're going to get negative 0.32. So in part B, it says interpret the roots. Since negative roots do not make sense in the context of the problem, since remember, we're launching a pumpkin and time is a unit of measurement, the pumpkin lands after 8.10 seconds. In example 2, it says real roots where the C value is negative. So again, it starts out as saying solve x squared plus 4x minus 17 using the quadratic formula. So identify your values. The A value is a positive 1. Leading coefficient for x squared is 1. The B value is a positive 4, and the C value is a negative 17. So you substitute in for A, B, and C. And when we get to the math inside, we get negative 4 plus and minus square root of 84 over 2. Remember, you need to do a product of square roots, which means 84 can be broken down into a perfect number, which is square root of 4, and then a prime number, which is square root of 21. When you solidify your math, you get negative 4 plus and minus 2 radical 21 divided by 2. And what they did is they took negative 4 plus 2 square roots of 21 over 2, and then negative 4 minus the square root of 21. 2 square roots of 21 divided by 2. We reduced our fractions. 2 went into 4. 2 goes into the 4 twice, and into the 2 once. That's where they got the negative 2 plus the square root of 21. Again, here we divided by 2, got negative 2, got a negative 1. So that's where we got the negative 2 minus the square root of 21. Then we took the square root of 21. Square root of 21 is the same as saying 4.58. So if we had to give a decimal result for this, we're saying negative 2 plus 4.58 or negative 2 minus 4.58. So we could have a result of 2.58 or negative 6.58. In example 3, it says solve using the complex roots. So they gave us solve 5x squared plus 8x plus 11 equaling to 0. Again, identify your pieces. The A value is 5, the B value is 8, The C value is 11. We substituted into our equation where we simplified and got to -8 plus and minus square root of a negative number. Remember, square roots of negative numbers, square roots of negative values, use the I value. We need to use the imaginaries. So 156 broke it down into square root of -1, square root of 4, square root of 39. Prime number, perfect number, our negative value. When we got through it, we got -8 plus and minus 2i square root of 39 divided by 10. Now here, when we look at our numbers are 8 an even number, 2 an even number, 10 an even number. They reduced by 2. They basically divided everything by a half. Half of 8 is 4, half of 2 is the 1, half of 10 is the 5. Results in -4 plus and minus I square root of 39 over 5. Because I is imaginary, you do not reduce this to a decimal form. This is your result in this piece. When we go to our check problem, we're going to try our check problem. It says solve 9x squared minus 3x plus 18 equals 0 using the quadratic formula. So we're going to identify our pieces. We have an A value of 9, the B value is -3, the C value is 18. So we're going to go x equals negative the B value, so I'm writing -3, plus and minus the square root. B is a -3 squared minus 4 times the A, which is 9, times the C, which is positive 18. All divided by 2 times 9. You have to set up your problem. We do our math here and we see negative and negative makes it positive 3, plus and minus the square root. -3 squared is a 9, minus 4 times 9, 4 times 9 is 36, and then 36 times 18 gives us 648. So I'm saying, remember, it's a minus sign, so it's minus 648, all divided by 2 times 9, which is 18. At this point, you do the math and sign. So I see 3 plus and minus square root. Remember, it's -648, so you're taking away 9 from that value, and we're getting -639 divided by 18. At this time, we need to find the factors of 639. So I'm not looking at the negative, I'm just looking at 639. If I add all my digits together, 6 plus 3 plus 9, that gives you 18, which you can divide by 3. If we did that, then I see square root of 3 times the square root of 213, which doesn't have anything that can work. But if I also think of the numbers 6, 3, and 9, you get 18. 18 is also divisible by 9. So if I do this, divide them by 9, 639 divided by 9 gives me 9 times 71. And that's where I'm going to go with. So I'm going to see 3 plus and minus square root of -1, square root of 9, square root of 71, all over 18. When we go to here, I see 3 plus and minus 3i square root of 71 over 18. And then you need to simplify and reduce. Notice it, 3, 3, and 18, they're all factors of 3. So I become 1 plus and minus I square root of 71 over 6. Okay, now using the discriminant. So in the quadratic formula, there's a discriminant piece. That is actually the piece is under the radical. And it says b squared minus 4ac. So based on what the result is, if you did that, it's going to tell you what type of solution you have. So if your b squared minus 4ac is greater than 0, it is greater than 0, you're going to have 2 real roots, which means they're rational. And here's the difference. It has to be a perfect square, like the result had to be a perfect square root. So you had to be a 9 so you had to be a 9, a 16, 121. Those are perfect square roots. If the root, when you did the math, was b squared minus 4ac greater than 0, but it was not a perfect number, not a perfect square root, you still have 2 real answers, but they're called irrational. So you're looking at numbers like, say you had 11 or 120 or 206. They're not perfect square root numbers. for that piece. Now, the b squared minus 4ac, if the result ended in 0, the result resulted in 0, you have one answer, it's a rational root, which means these are your perfect square trinomials. So for example, if you had the form, you ended up in the form of a plus b squared or a minus b squared. Those are your perfect square trinomials. Now, if you had the result happen to be b squared minus 4ac, resulted less than 0, you have two complex numbers. These are your imaginary values. Your imaginary answers means they result in the letter I. In example 4, it says the discriminant, we're going to apply those pieces. So it says examine 2x squared minus 10x plus 7 equal to 0. So for part A, they want you to identify your values. So our A value is a 2, the B value is negative 10, and the C value is 7. And then we're plugging into our formula that says b squared minus 4ac. So I'm writing negative 10 squared minus 4 times the 2 times the 7. Negative 10 squared is 100, and then 4 times 2 is 8, times 7 is the negative 56. 100 minus 56 is 44. But then it says describe the number and type of roots. So we know that our discriminant is non-zero, which means it was greater than 0, so we have two roots. But because it's not a perfect square, the roots are going to be irrational. Remember I said perfect squares give you rational answers. Non-perfect are irrational, which means on a curve, the problem is going to be opening up. It hit in two spots. It hit in two locations, but they were not perfect numbers. They were not solid. On example 5, the discriminant, they wanted complex roots. So again, identify your A value, B, and C. In this instance, it says examine negative 5x squared plus 10x minus 15 equals 0. The A is negative 5, the B is 10, and the C is negative 15. So I plugged in my B value, which is 10, my A value is negative 5, and my C value is negative 15. So 10 squared is 100, negative 4 times negative 5 is positive 20, positive 20 times negative 15 is negative 300, which gives us negative 200. Now, because the discriminant is non-zero, there's going to be two roots. But because it's negative, the roots are going to be considered complex, which means we have imaginary answer.